Hey everyone, welcome back to AP Precalc. This is lesson 3.11. Let's get right into it. All right, so here's the bell ringer for today. For these three questions, you are allowed to use Desmos or your graphing calculator. Pay very close attention to the explanation of these, and come to office hours if you really don't understand any of these, because after 3 PE and 3 PF, the next day you will have a very short Desmos quiz covering both of these bell ringers, just to make sure that you know how to use Desmos appropriately, especially since the last few tests have been no calculator. All right, so let's start with number one here. Here we have the functions f and g, which are both polynomials, and we want to find the zeros of these two functions being added together, defined as h of x. So what we're going to want to do here is have a Desmos screen like so. This is what you should see on your Desmos screen. So here, notice in row one, I literally typed in f of x verbatim. I didn't change anything about it, and that's what you want to do in Desmos. Then I entered g of x, the exact same verbatim, nothing new there. And I even included the f of x equals and the g of x equals. And that's really important for the third line or row, which I have h of x equals f of x plus g of x. That way, I also know these three lines will be different colors, and we are looking for the zeros of the green line of our third function there. And so I'm going to find our two zeros, which are, remember, zeros are where it intersects the x-intercept, or the x-axis. And so our two zeros should be answer choice C, which is negative 2.706 and 3.563 here. And so those two should be our answers, answer choice C there. So make sure you're looking at the right equation, you're finding the right zeros. If you want to hide the red and blue lines, simply click on those colors one time, and it will hide those graphs visually, so that way, when you're only looking at equation number 3, it's a lot simpler to do so. All right, number 2, the periodic function p is given by sine 2.6x plus 2 cosine 0.8x. What is the period of the function p? And so this is what I have in Desmos. I actually just graphed the function. You could put p of x equals if you want. You don't need to. And then from this graph here, you really want to look for a key characteristic about the graph and look from x value to x value. Taking a look here, I see that this is a very tricky function because everything looks pretty similar. But I see that there's kind of like an M shape, right? That's pretty symmetrical right here. So I'm going to take that minimum, and that point is 15 pi over 2 as our x coordinate. So our x coordinate here is 15 pi over 2. I'm looking around and seeing the next time I see that symmetrical M shape, that's right here, which this x coordinate is 35 pi over 2. And now, just very simply, right, on a number line, if I had 2 and I had 5, how do we find the period of this function? If this is a max and like that's a max there, you do 5 minus 2. It's going to be the same thing here, and a lot of students kind of have trouble with that, especially when you're working in terms of pi. But what we want to do is you want to do 35 pi over 2 minus this x value. So the bigger x value minus the smaller x value, which is 15 pi over 2. Here you'd get 20 pi over 2 or 10 pi. Typing that into your calculator, or you could do what I did on Desmos and convert each one to a decimal, and then just subtract the two decimals to get 31.4156 or 31.416 A as the correct answer. If you do 10 pi, you would also get that as a decimal approximation as well. On your quiz, I will want the period as a decimal, not in terms of pi. All right, and then number 3 here, the function r is given by r of t equals 8.4 ln 1.7t plus k. If you know when you plug in 5 for x, you get 21.3. what is the value of r of 3? So let's see what we have here. The first thing we're probably going to want to do is find what k is so that we have an equation, a full equation, to plug 3 into. So let's see if we can find what k is here. So let's plug in our 1 point that we do know, right? We know 21.3 is going to be our y value equals 8.4 ln 1.7 times t, which is 5 in this case, plus k. And now let's solve this. So I'm going to do 21.3 in my calculator divided by 8.4. Here I get a long decimal. Do not round until your final answer. So do not round. I'm even going to write this so you guys know not to round until your final answer. Otherwise, everything will be off. So here you should get 2.535714286 equals ln, and then 1.7 times 5 plus k. Remember, ln is log base e. So now I'm going to convert this from logarithmic to exponential. So this should be e to the power of 2.535. I'm not going to write it all out, but I'm going to keep that exact value in my calculator, equals 1.7 times 5, which 1.7 times 5 is 8.5. So I'm just going to simplify that. I think we can do that to get 8.5 plus k. Once we have that, I'm going to subtract 8.5, but I'm going to first evaluate this as a decimal. So e to the power of that should be 12.625 dot 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 minus 8.5 will equal k. So I'm going to subtract 8.5 from that. Again, I'm using the exact values in my calculator. I'm just doing it step after step after step. That's what you should be doing too, whether it's on your calculator or on Desmos. Here you should get k equals 4.125445807, giving all the decimal places that I see on my calculator. And then we want to use this to find r of 3. So here you're going to plug 3 in for t, but we know k now. So 8.4 ln 1.7 times 3 plus 4.125 dot dot dot. So I'm going to do that. I'm first going to evaluate the inside. So 1.7 times 3 is 5.1. And then I'm going to add that to my long decimal 4.125 dot 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 to get 9.225 dot dot dot. And now I'm going to do the natural log of that number to get 8.4 times 2.22196 and so on. And then I'm going to take this number and multiply it by 8.4 to get 18.66451032. And then here we can round to 3 decimal places, 665, which should be answer choice C. So notice how if you even rounded by like 1 or 2 decimal places, it would mess up the entire equation. You want to keep the exact answer until the very end, especially because this is one question that probably will be reseen on the quiz. So just be prepared for that. All right, so now let's get into today's actual lesson. Today we're going to be talking about secant, cosecant, and cotangent. So just when you thought trigonometry couldn't get any more exciting, today we're going to add 3 new trig functions. Yay. The good news is they're pretty easy, right? It's not like it's going to be 3 brand new ones. They're pretty much building off of sine, cosine, and tangent, and they are just the reciprocals of them. So these shouldn't be too difficult for us to understand. Let's take a look at what I mean. So here, what secant is secant's the long name. We abbreviate it as SEC, just like how we don't write cosine. You just write cos, C-O-S. Secant is 1 over cosine, where cosine is not equal to 0, because this is something that you'll see a lot today, right? If you have 0 over a number, the reciprocal of that is a number over 0. And a number over 0 is undefined. So just make sure you kind of remember that fact. That will be very important today. Cosecant, We abbreviate that as CSC, cosecant. And then this is 1 over sine. And then cotangent, we're just going to take the first 3 letters. We abbreviate it as COT. And that is 1 over tangent. Remember, tangent is sine over cosine equals tangent. So then cotangent should be the reciprocal, cosine over sine, right? So how do I remember whether secant goes with sine or does it go with cosine? I don't know. Just remember this, opposite letters go together. So sine will go with cosecant. So the first letters are opposite, and then cosine will go with secant. And so the first letters of those two are opposite. And then obviously it's going to be pretty easy to remember tangent and cotangent. Those just kind of pair together naturally. And so that's how I remember those 3 functions there. All right, so graphing each function. You will never be asked to graph them on an AP exam, but it is important to know how the graphs are kind of derived. When you know the graphs of sine and cosine, we can kind of figure out the graphs of secant and cosecant as well. And so they will include vertical asymptotes because for the first time ever, you're going to have times where the denominator is equal to 0, where sine or cosine is equal to 0. So to sketch the graph, and I'm going to work through this, we're going to graph the function of sine or cosine, draw our vertical asymptotes whenever sine or cosine equals 0, because when you have sine equals 0, right, for cosecant, that would be 1 over sine, which equals 0, which is 1 over 0, which is undefined. And then we are going to flip the function upside down, keeping the peaks and valleys as possible points. So here, for sine, this is a graph of sine from 0 to 2 pi. What we're going to do here is whenever sine is equal to 0, we're going to draw a vertical asymptote now. So let's do that. That will be at 0, at pi, and then at 2 pi as well. And then let's take a look here. When sine of theta equals 1, the way we're going to draw a reciprocal is basically think about reciprocal as like flipping a fraction, right? If you have a numerator over denominator, the reciprocal flips it. We're going to do that same thing to the graph. So we're going to keep our maximums as points, and then the other points we're going to flip as a fraction, where these will get closer and closer to the vertical asymptotes, like so. And so obviously this will continue, right? When this continues, our graph of, and remember this is the graph in purple that I'm drawing, is the graph of cosecant of theta there. Not this part there, that's just to continue. I should draw that in red there. All right, so that's how we're going to kind of sketch the graph of cosecant. Just remember the zeros become vertical asymptotes, and then the points of maxes or mins will be the same on both graphs there. All right, so for cosine, let's take a look here. We have some zeros at pi over 2. That will now become a vertical asymptote for secant, so that's what I'm drawing here. And then 3 pi over 2 will become a vertical asymptote as well. Any max or min, we're going to keep those as points, so at 0, pi, and 2 pi. And then we're going to flip it. So flipping it like this, where those will go down, this, where those go up, same thing here. This is what the graph of secant will look like as well. It's not really important that you need to know how to graph it, but pretty much just graph it as if it was sine or cosine, so with transformations as well. And then do what I did, take zeros, turn them into vertical asymptotes, keep the max and min as points, and then kind of flip the graph for each part there. All right, so this is what secant and cosecant should look like. Remember, secant is going to be the inverse of cosine, and then cosecant is going to be the reciprocal, not inverse, sorry, of sine as well. Here we have the dotted line is sine and cosine, but the black lines are what secant and cosecant are. Let's look at the vertical asymptotes. The graph of secant, just the parent function, so this is the parent, This is not including transformations. We'll have vertical asymptotes where cosine is equal to 0, which from the unit circle is going to be when your x-coordinate is equal to 0, which is at pi over 2, 3 pi over 2, 5 pi over 2. So pi over 2 plus pi k will be where cosine is equal to 0. Same thing for sine. Sine is your y-coordinate. So that is going to be at 0, pi, 2 pi, 3 pi. So 0 plus pi k, or we just write just the pi k, where k is an integer, will be the vertical asymptotes for the reciprocal for cosecant there. All right, and then also notice the range. The range is going to be from -1 to 1, would typically be the range for sine and cosine. However, because it's the reciprocal of that, basically that's going to be everything that's not our range for secant and cosecant. So our range for secant, if we look at this graph, goes from -infinity all the way up to -1. So we would write -infinity to -1, and then you go from 1 all the way up to infinity, right? Those go up forever. And that is going to be our range for secant, but also for cosecant there. You'll see the exact same thing as secant. So just remember the vertical asymptotes will be formed when the reciprocal function, which is either sine or cosine, is equal to 0. All right, so for tangent and cotangent, there's two things that we really have to think about. First off, if you have tangent here and then cotangent here, wherever tangent is equal to 0, that's 0 over a number. If we take the reciprocal of that, you're going to get a number over 0, which is undefined. And so any 0 for tangent will become a vertical asymptote for cotangent. Likewise, if we have the vertical asymptotes for tangent, because they do exist for tangent, that's going to be a number over 0. That will now turn in to just a 0 for cotangent. So if we take a look at the graph of tangent here, we're going to get something that looks like this. This is the graph of tangent in red, and then cotangent is in black. Let's take a look at where tangent is equal to 0. Here we see zeros here at pi and at pi over 2. And so zeros will turn into vertical asymptotes for cotangent, which we see there. There's one on the y-axis. They don't show it because it blends in with the y-axis. And then one right there as well. Now let's also take a look at potentially where there's vertical asymptotes for cotangent, or for tangent, which is at pi over 2 and negative pi over 2. Those will become zeros for the original graph of cotangent. So erasing everything that we know now, we can kind of see that trend right there. Right? So if we kind of erase the graph of tangent, we see that the vertical asymptotes that we would normally see at pi over 2 and negative pi over 2 become zeros now. And then the zeros where we would normally see it at negative pi, 0, and pi become vertical asymptotes for cotangent. So cotangent will have the vertical asymptote equation of x equals 0 plus pi k, or x equals pi k for cotangent there. All right, so now two things you need to know about secant, cosecant, and honestly cotangent as well. So I'll add that in there, cotangent of x. First off, you'll be asked questions about the vertical asymptotes of them. Pretty much memorize where sine or cosine is equal to 0. This is very similar to what we did with tangent back in 3.8. Memorize where they're equal to 0, and then shift it based on your b value. So for example, if we said, what is the vertical asymptotes of cosecant of 1 over 4x, right? Well, I know cosecant's reciprocal is sine. And I know sine is equal to 0 at x equals 0 plus pi k. Now, I see a b value of 1/4, which means that that is stretching the graph out by 4. That's a horizontal dilation by a factor of 4. So I'm going to take this whole equation and multiply it by 4. to get x equals 0 plus 4 pi k. And that's going to be our equation for the vertical asymptotes of cosecant 1/4 x there. All right, for the range is just going to basically be for secant and cosecant. Imagine you're finding the range of sine or cosine, and then just take the absolute opposite of it. So, for example, if we have 3 sine of x plus 2, right, we would see the midline at 2, and then our amplitude would be 3. So -1 and 5 going 3 up, and then 3 down from 2. Our range would be -1 to 5, including those values. So the range for the reciprocal of that, 3 cosecant x plus 2, would be basically everything but the values from -1 to 5, which means you're going to go from -infinity to -1 and from 5 to infinity. So we're not going to include any number between -1 and 5, except for those two numbers there. The outsides will include in our range, so that's how we figure out the range for secant, cosecant, and then cotangent. Based on the graph you saw last slide, the range is all real numbers as well. All right, so for example number 1, these are a few questions. You'll see one or two of these on your next quiz. So here, let 3 secant 2x, what is a vertical asymptote? So this reciprocal is cosine. Cosine has zeros at x equals pi over 2 plus pi k is the vertical asymptote equation for secant because it's the zero equation. Where are the zeros for cosine? Taking a look there, we now see 2, which is a horizontal dilation by a factor of 1/2. So we're going to take this whole equation and multiply it by 1/2. We then should get pi over 4 plus pi over 2k. And then seeing which one of these fits, I see pi over 4. So that should be our answer there for example 1. Example 2, we have 7 cosecant x. Here, the reciprocal of this is sine. Where is sine equal to 0? That's going to be at 0 plus pi k. And then we just want to see which one of these 4 asymptotes would fit in that equation. There's no b value, so this is just going to be our vertical asymptote equation for cosecant because it's a 0 equation for sine. Here, assuming k is like 1, you'd get pi, so A would be the correct answer there. All right, so for example 3 here, we have let h of x equals 3 cosecant theta over 2. What can you give the range? So here you're only focused on your amplitude and your midline, which in this case is 0. So we won't really have to worry about that. As a graph, what this would look like is if you have 3 and then -3, and we had the graph of sine, and then we took and wanted to find here the reciprocal, it would look a little something like this, where you're going from -infinity all the way up to -3, and then basically skipping any value from -3 to 3, and just going from 3 to infinity. So C should be our answer there. For D, very similar to secant, so this is going to be the reciprocal of cosine. That won't really affect our range. And here, if we graph 2 cosine 3x, that would just be like this, right? Where we are going from +2 to -2. And then the reciprocals would be like that, basically every value except from -2 to 2. So B would be our correct answer for example 4 there. All right, example number 5. This one's a little tricky. We want to first find the vertical asymptotes on this cotangent graph. So the vertical asymptotes for cotangent is going to be the same as where is tangent equal to 0. And this, remember, is going to be the same. Tangent is sine over cosine. So tangent will be equal to 0 when sine is equal to 0, which is at x equals 0 plus pi k. And so that will also be the tangent equation for 0 and the vertical asymptote equation for cotangent. Now this is 0 plus our period times k for cotangent, or just tangent. And so we want to find what is our new period, which is our b value is equal to 2 pi. So our period is going to be not pi over our b value, or not 2 pi over our b value, but pi over our b value, to get our period to be 1/2 in this case. So then this should be 0 plus 1/2 k, and the only one that fits that is option choice B. So B should be our answer for example 5. You probably won't see anything like that on a quiz. So now we're going to want to solve equations that involve secant, cosecant, and cotangent. So it's going to be very similar to the equations we solved with sine, cosine, and tangent, just with their reciprocals. So basically what you're going to want to do is isolate the trig function first, right? Get that by itself on one side. Once you have that, then take the reciprocal of both sides to convert it into a sine, cosine, or tangent equation, and then just solve it like we have been solving it in the past. So let's walk through a few examples. Here, example 6. These are going to be a little easier than what you've seen in the past. So 3 cosecant x equals -3, and solve from 0 to 2 pi. Here I'm going to divide both sides by 3 first, and then I'm going to take the reciprocal. So the reciprocal of cosecant is sine of x equals, and then what's the reciprocal of -1/1? You flip that, it's still -1. So here x should be 3 pi over 2 is where sine of x is equal to -1. So that should be our answer for example number 6. Example number 7, we have 4 minus 2 secant x equals 0, and we want to solve from 0 to 2 pi. So I'm going to subtract 4 from both sides. -2 secant x equals -4, and then divide both sides by -2 to get secant x equals +2. Once we have this, remember this is +2/1, just to get it into a fraction. So then when we take the reciprocal of secant is cosine of x equals the reciprocal of 2/1, which is 1/2. And then here, where's cosine x equal to 1/2? That's going to be pi over 3 in the first quadrant, 60-degree reference angle. And then cosine is also positive in the second quadrant, fourth quadrant at 5 pi over 3. So those should be our two answers there. All right, example number 8, we have 4 cosecant x plus 3 equals 11, and we want to find the coordinates of the x coordinates of the intersection points. So basically set the two equations equal and solve for x. I'm going to subtract 3 from both sides to get 8, divide both sides by 4 to get 2, and then take the reciprocal of both sides. So sine of x equals 1/2. Here, remember, it's just +1/2. You're looking from 0 to 2 pi. So x should be pi over 6, and then 5 pi over 6. There, just using the unit circle, so that should be your answer for example 8. Example 9, here we have 3 minus 1/2 secant x equals 4. I'm going to subtract 3 from both sides. -1/2 secant x equals 1. And then I'm going to multiply both sides by -2 in this case to get rid of that negative sign and the 2 in the denominator to get secant x equals -2. And then take the reciprocal of both sides. This is -2/1. So that you should get cosine x equals -1/2. Here, x would be equal to, cosine is going to be negative in the second and third quadrant at a 60-degree reference angle. So 2 pi over 3 and 4 pi over 3 should be our angles from 0 to 2 pi there. All right, so here we're going to work with problems that involve reciprocal trig functions like secant, cosecant, cotangent, but also with a squared term. So just remember, take the reciprocal before you take the square root. So let's do that here. Let's work through a few of these problems. We have 1/3 cotangent squared x equals 1/9, and we're solving for angles in between 0 and pi. Here I'm going to start by multiplying both sides by 3. to get rid of that 1/3 there, to get cotangent squared x equals 3 over 9 or 1/3. From here, I'm going to then take the reciprocal of both sides to get tangent squared x equals 3 over 1 or just 3. And now I'm going to take the square root of both sides. Here you should get tangent x equals, and now remember, very important, the plus or minus root 3. This is going to be at a 60-degree reference angle, so we are going to include every 60-degree reference angle, which, however, remember, you're only looking for these two because you're only going from 0 to pi. So this is going to be pi over 3 and 2 pi over 3 should be your only answers. On the AP exam, they actually don't mark off points if you add more solutions, but if they're wrong, obviously they're going to take away points and you won't get credit for the question. So I would say it's better safe than sorry. Don't include solutions that are not inside your domain. Right, example 11. Here we have -3 plus cosecant squared x equals 1. Again, we're solving from 0 to pi. I'm going to add 3 to both sides to get cosecant squared x equals 4. Then I'm going to take the reciprocal of both sides. So sine squared x equals 1 over 4. And then take the square root to get sine of x equals plus or minus. And then the square root of 1 over the square root of 4 is 1 over 2. So plus or minus 1/2. This then should be any 30-degree reference angle from 0 to pi. So that's just going to be x equals pi over 6, and 5 pi over 6 should be our two answers there. Right, so that's 10 and 11. All right, so example 12 here. Here we just have a few graphing questions. So let f of x equal that equation there. In the xy plane, what are the x coordinates where f of x equals -5 from 0 to 2 pi? So this is what it should look like in Desmos. Here we are graphing the equation. That's our equation in blue there. And then at y equals -5, we're looking for x coordinates, and we're looking from 0 to 2 pi. So you could either type that in and it would shade it, or just know 0 goes here, and then 2 pi is around 3.14 times 2, so it's around 6.28. So our only intersection point would be right here. So our answer should be x equals 2.597 or 598, depending on if you want to round or not. So that should be our answer for example number 12. And then 13, very similar. What are the x coordinates where that is equal to 2 from 0 to 2 pi? So this is what it should look like here. Graph both equations. Remember, it's y equals 2, not x equals 2, because we're looking for our x coordinate. It's going to be that point right there. Just click on it to highlight it, and then our answer should be x equals 4.078 should be our answer for example number 13. No rounding there, and so that should be it. If you have any questions, please come see me in office hours, and I will see you guys later. Thanks.